Jubilant wishes to all. We are the students of R&D Engineering College, ECE department. The mini project that we have chosen for the subject EC8453 Linear Integrated Circuits is LED Chaser Circuit. The team members are K.S. Subashri, B. Sophia, Varshini Sagarika, and Shaikh Kamilun. Our project mentor is M. Jyoti Prasad, Assistant Professor of R&D Engineering College. Let's move on to the introduction. So, what is this LED chaser circuit? How are these LEDs connected? LEDs are simply connected to the output terminal of the IC in series. The LED lights one by one for a period of 1 second and the cycle repeats, giving a running light appearance. Power supply required is 6 volt to 9 volt, but we can also use power supply circuit to keep LEDs continuously turned on. Over to Sheikh Kamilun.
So the components used in this circuit are 555 timer, resistors, capacitors, DC voltage source, LEDs, and an oscilloscope. This is the circuit diagram of our circuit. We have done this in a simulation settings. The NI Multisim, formerly Multisim, is an electronic schematic capture and simulation program which is part of a suite of circuit design programs along with Altiboard. We have used this simulation for this project. It is widely used in academia and industry for circuits education, electronic schematic design, and spice simulation. The timer which we have used here is a 555 timer. The basic timer gets its name from the fact that there are three internally connected 5 kilo ohm resistors which it uses to generate the two comparators reference voltages. It is a very cheap, popular and useful precision timing device which can act either as a simple timer to generate single pulses or long time delays or as an relaxation oscillator producing a string of stabilized waveforms of varying duty cycles from 50% to 100%. The 555 timer chip is extremely robust and a stable 8-pin device that can be operated either as a very accurate monostable, bistable, or astable multivibrator to produce a variety of applications such as one-shot or delay timers, pulse generation, LED and lamp flashes, alarms, and tone generation, and in fact, any circuit that requires some form of time control as the list is endless. I over this to Sophia.
Here comes working principle. IC1 NE555 is a popular timer IC wired in the astable multivibrator mode. Resistor R1, VR1 and capacitor C1 acts as the timing components and the output pulses are available for the output pin 3 of IC1. These pulses are given to the input pin 14 of the Johnson Decade Counter IC CD4017. Out of the 10 outputs of IC2, 8 outputs are used to drive the LEDs. The ninth output pin is connected to the reset pin 15 to stop the counting, so that the cycle repeats. With the value of C1, each LED remains on for 1 second. When one LED turns off, the second one turns on. This cycle repeats giving the running light appearance. Resistor R3 keeps the input pin 14 of IC2 low after each pulse. VR1 adjusts the speed of LED chasing.
Now let's look at the simulation of the project. So here is a triple five timer IC, and this is the oscilloscope to look at the output waveform. V1 as a 9-volt DC supply. Two resistors R1 and R2 are used. R1 is 1 kilo ohm and R2 is 3.9 kilo ohm. And here is a capacitor C1 of 1 microfarad. This capacitor C1 will decide the fall time and the rise time of the waveform. That is how quickly the LED turns on and off. When capacitor values increase, the LED blinks slowly. The resistor R2 decides the frequency of the LED. When R2 is low, the frequency is high. And the resistor R1 decides the threshold of the waveform. Now let's look at this output. So the LED blinks one after the another, the output of which is obtained in the oscilloscope. Now let's try increasing the value of the capacitor and look at the waveform. When the capacitor values increase from 1 microfarad to 3.9 microfarad, the frequency of the waveform decreases.